So the hyperconjugation is of two types, minus H and plus H. Minus hyperconjugation and plus hyperconjugation. Plus H and minus H. So first is plus H. It is an electron releasing effect, means the sigma bond between the C and H transferred to the empty orbital of the neighboring carbon atom. So here it is a electron releasing effect. In this, CH bond breaks and sigma electrons overlap with empty p orbital of neighboring carbon atom. For example, C, H, H, the same example we have taken earlier, it is CH2 positive. Now in this positive charge, this is the CH bond, next atom is carbon. So these transfer to the empty orbital, overlap with the empty orbital and make the pi bond. It becomes positive and here is hydrogen, hydrogen, and it becomes this. The next resonating structures also there, but here I am going to only explain you, that's why I am not making that. So here the electron releasing effect. So hydrogen is releasing the electrons, right, and gets positive charge. In this CH bond breaks, this CH bond breaks, and sigma electrons, these sigma electrons overlaps with the empty p orbital or of neighboring carbon atom. It is off actually. It is off, not or. So it is of neighboring carbon atom, right? So here, so if we are going to make the resonance hybrid of this, the resonance hybrid will be H, H, C, CH2. Here this bond is going to break. This also have the same probability. All the alpha hydrogens have the same probability to make the resonance, right? So here this is the resonating structure, and because of this resonating structure you may observe that here between C and C somewhat double covalent character is there, somewhat double bond character is there, right? Character taking place, and that's why so the bond length decreases. So the bond length decreases. So because of the H effect, the bond length decreases because the resonance takes place. This is the kind of resonance, and thus the double bond character come in existence and the bond length decreases. So here the same condition is with the free radicals. Let me show about the free radicals. C, H, H, CH2. This time here is the free radical, right? So it needs one electron, and here is the two electrons. So one electron come here, this side, and this one electron go to the hydrogen. This, the resonating structure will be X, CH, CH. Here is the double bond, and here is the CH2, and here is the free radical. Right? The next resonating structures may be possible if you are going to show that. I am showing here the next resonating structures. C, H, free radical this time, this hydrogen, and here is the CH2, right? Next resonating structure H, C, H, this time free radical with this hydrogen and CH2. All the alpha hydrogen have the same probability to take part in the H effect. So here this and the resonance hybrid of this will be C, H, 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 CH2, and bond breaking, and here formation takes place. So this is the resonance hybrid of the given species. So this is the plus H effect. Now move to the minus H effect. So here comes to the minus H effect. In minus H effect, it is an electron withdrawing effect. When the atom attached to the carbon atom with the sigma bond breaks and the atom attached to the carbon gets the negative charge, right? So here let me write the definition first, and after that I am going to explain with the help of example. So here the second type is minus H. So it is an electron withdrawing effect. In this, sigma bond between carbon and some atom. Here is some atom, right? Not hydrogen I am going to take here, because I am going to take some another example. So here carbon and some atom. The sigma bond is there. So it breaks and the atom attached to carbon gets negative charge. For example, let's take the example this Cl, right? In this, the chlorine atom is there. It is more electronegative than carbon. It attracts the sigma electron between the carbon and chlorine. So here between carbon and atom. So this time atom is chlorine, right? So here this sigma bond attracted by the chlorine atom, and here is the conjugation, sigma and double bond. So this double bond delocalizes here. Now the next resonating structure will be double bond, positive charge on this carbon atom this time, and here comes the double bond, Cl, and this Cl gets the negative charge, and sigma bond breaks negative charge on the attached atom, right? Now the next resonating structure will be, this comes here, now positive charge on this carbon, so double bond here, double bond C, Cl, and Cl negative, positive charge on this carbon atom this time. Now again the delocalization takes place and positive charge come on this carbon this time. So the next resonating structure will be double bond, and here comes positive charge. Here is the double bond Cl, and the Cl negative atom. So here now again this comes here and this comes here. So the next resonating structure will be double bond, and here comes the single bond Cl, and Cl, and these 3 alpha chlorine atoms are present. So all chlorine atoms attached to the carbon take part in the resonance H effect. So this kind of resonance, more are the alpha atoms, more will be the resonating structures, more will be the stability of the molecule. So the resonating structures are equal to the number of alpha atoms, whether it is hydrogen or any other atom, right? So here, because of the benzene ring, this shows the 5 resonating structures, because benzene shows the 5 resonating structures. So here, the resonance hybrid is delocalization takes place, and here is the C. Now Cl, 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 and bond breaking, right? And here is double bond character. So somewhat double bond character, somewhat and double bond character come in existence, exist. That's why the bond length decreases. So bond length decreases, right? So this is the minus H hyperconjugation effect, minus H effect. You may observe here, because of the minus H effect, the electron density in the benzene ring decreases at ortho and para positions, right? Because of minus H showing atoms or group of atoms or groups. The positive charge, or you may say electron density decreases. At ortho and para positions in benzene ring. Minus H effect, also called reverse effect. It is only shown by the Cl3 group, right? Only shown by CCl3 group. That's why I am taking here this example, right? So now